let's take a look at Euler's method. Now, if you want to learn exactly how Euler's method works, I recommend you to watch some YouTube videos out there that shows the full visualization of essentially getting the approximation of a function using differential equations. But for this video, that's going to take way too long, so we're going to just go ahead and do an example problem right away. So, calculate an approximation. Remember that Euler's method allows us to get an approximation of a function given the differential equation. So that is going to be the key of the question. Calculate an approximation to y at 0.2 for the initial value problem dy by dx equals x plus y, where y 0 equals 1 with step size h equals to 0.1 using Euler's method. So Euler's method is represented by this iterative equation. So the n represents the iteration, and you start with n equals to 0. So you get y1 equals to y0 plus h f prime x0 comma y0. And this point right here essentially represents the initial value, so this is going to be 0 comma 1. So 1 plus h f prime 0 comma 1 equals to 1 plus 0.1 times, and this is f prime, so that is going to be 0 plus 1. And y1 is going to be equal to 1.1. And you have to note that we are going from 0 for the x value, and then the step size is 0.1, so we're increasing by 0.1 each iteration. So y1 is really just approximating the value at x equals to 0.1, not 2, sorry. And this is approximately 1.1. But right now the question asks for you to find y 0.2, so we gotta do one more iteration. This is going to be equal to y2 equals to y1 plus h f prime x1 comma y1. So y1 was 1.1. This is why it's an iterative process. You are using the result from the last result. So plus 0.0, not 0.0, but 0.1. And f prime x1 comma y1 is going to be 0.1 plus 1.1. So I'm going to use my trusty little TI-84 to calculate this, and we get 1.22. So an approximation of a 0.2 is approximately as 1.22. That is how we would use Euler's method.